So our movement chapter practice problems are pretty much solved. So all that is left is that you attempt the worksheet, and any problem that you have, we'll solve them in due time. Many of you might have already solved it because you had access to the paper and your exams were at hand. Maybe you have already solved it. It's a pretty old booklet. So I'm actually trying to push through the uh, up to the distributed chapter and trying to get to the next topic. That's why I'm bringing up the next chapter's theoretical class, which happens to be work energy power. Work energy power is a pretty small chapter. Doesn't have much too difficult things in it, but there are certain stuffs that you need to be careful about, which I will warn you in as I go through the lecture. So this is the short form for work energy power chapter, WEP. You'll see this in a lot of other cases. So let's just go ahead and define the variables that we have. My voice started. Right. এখন কি অবস্থা? Hello? Same.
Sir, same.
এখন distorted.
Yes, sir.
What kind of distortion is that? Like, is my voice breaking up or what? Is it too low?
No, sir, it's breaking up.
Breaking what the fuck? Break হবে কেন? Let me check. Wait. Internet connection seem to be working fine. এই problem কিভাবে solve করা যায়? So দাঁড়াও আমি আমার মোবাইল থেকে ওয়াইফাই দিয়ে মাইক্রোফোন দিয়ে কানেক্ট করছি, একটু ওয়েট করো। Okay, so we had some technical difficulties. We solved it by different method. I hope that works. So in the work energy power chapter, we have basically three things: work, energy, and power. Then we have some additional stuffs. We have what we call efficiency. That is a pretty interesting thing, efficiency. And then we have a pretty important topic for which students sometimes find it pretty difficult to handle, is that energy sources. So energy sources, and you have to just the reason it can prove to be a bit difficult because you have to individually know that what type of energy is contained in what type of source. For example, food contains chemical energy. Whenever we eat it, our body naturally converts a portion of the chemical energy into heat energy, and our muscles convert them into kinetic energy. And so there can be a lot of different type of conversions. And then whenever we move ourselves or push something, that chemical energy that we provided into our body converts through kinetic energy of the muscles as effective work that goes out of our body through our muscles also. So that type of energy conversions is something that is pretty important for us to understand. Similarly, if I give you some other example, let's say considering a resistance to be significant, if we throw a ball vertically above, as the ball goes up, its energy conversion would be GP, sorry, not GP, my bad. So at the beginning, at the starting point, we are providing the ball some kinetic energy. So initially the ball has kinetic energy. As it keeps going up, its kinetic energy will be simultaneously converted into GP and also some heat loss. Heat loss comes from the air resistance. If air resistance did not exist, it would be only converted to K into GP. And then the ball reaches to a certain height, and then the ball starts to fall back once again. At this height, K is 0 because the ball has no speed. GP would be, I'd say, maximum. I don't know what the value is because we don't need that. Then as the ball will start to fall downwards once again, then the conversion would be this amount of stored GP, which happened for the rising duration. This GP, the heat loss is already lost to the surrounding, or the heat loss has already heated up the ball. some of the heat can be contained within the ball, some of the heat can be going to the surrounding. It can happen, but there will be some heat loss. And then a portion of the kinetic energy would be stored in the ball as Gp. And then as the ball falls down, this Gp would then start to convert back into kinetic energy. And once again, as the ball falls down, it will be colliding with the atmospheric particles, air resistance will work. So we'll once again have heat loss. What is really important, the places where the students mess up is that sometimes whenever they are trying to draw this kind of flowchart, so write this kind of flowchart, giving this plus sign over here, students sometimes give another arrow. This is wrong. Giving a plus sign means that K is converting into Gp and heat loss simultaneously. Whereas if we give a plus, if we give an arrow over here, this would mean all of the Gp converts to, all of the K, initial K converts to a total Gp first, then somehow all the Gp converts into heat loss. That's not the case. As the ball goes up, a portion of its kinetic energy is lost due to air resistance. The remaining part goes as the Gp gain. Similarly over here as well. So you have to be careful that in which places you should you give arrow, in which places should you give plus. Yeah, for example, if I try to give another example for energy conversion, let's consider an automobile vehicle that moves by some IC engine, internal combustion, petrol engine, diesel engine, octane engine, whatever. So how does the energy conversion happen? We feed the engine oil, or if it's a CNG car, we feed the engine gas. So we are basically providing a source of chemical energy, which is burned in controlled explosions in the engine. So first of all, chemical energy, you have to write this thing. All chemical energy converts into heat energy as it is burned. All the chemical energy is converted into heat energy. From this heat energy, some energy is lost to the surrounding as loss. That's where the radiator of a car comes in, because you have to cool down the engine block for it to work. If we don't do that, the engine is going to stop working. Out of this heat energy, a portion is lost to the surrounding, and then the remaining portion of the heat is converted into kinetic energy of the pistons. The pistons move up and down, which necessarily rotates the driving shaft. So that is still kinetic energy. In the up and down motion, the kinetic energy in one alignment, the rotary motion is in another alignment, but still we still have kinetic energy. And then we have kinetic energy. And in the process of heat to kinetic energy, we also have some additional loss happens over here. So the reason I'm showing you this thing, that heat converts into, I have two arrows, meaning that this heat energy is converting to kinetic energy and loss simultaneously. This is one way to represent this. The alternative way that can be like this: chemical energy converts to heat energy in the engine, and we have some heat loss. Then you can give another arrow like this. So now the heat is converting to kinetic energy, and along with this kinetic energy, we'll also have some loss, because all the kinetic energy will not be used to actually provide motion to the car in the motion system, in the shafts of the rotating parts or moving parts of the engine will have some friction, and that friction is going to also be responsible to absorb some part of that available energy. So this is how these things should be drawn. So important for you to understand precisely that where should you give an arrow, where should you give a plus. So এই জিনিসটা যাতে আমাদের গড়বড় না হয়, এটা নিয়ে আমরা careful থাকবো. And the other thing that is pretty important for you to understand what type of object give what type of energy. There are not too many examples for this, but the examples that we have, some students tend to mess them up, or sometimes they seem to they have a bit of confusion. For example, if I just give another example, what type of energy do we receive from the sun? From the sun, we receive light and heat, which reaches the earth in the form of electromagnetic radiation. What is the source of energy of sun? Do any of you know?
Nuclear fusion.
Yeah, nuclear fusion is the name of the process. For example, in the IC engine, controlled explosion.
Hydrogen is the source of the sun.
Exactly. Hydrogen is the name of the material which works as the sun. But in that case, we are not having actually what we define as burning. Burning of any fuel in nuclear terms means should be reacting with oxygen. in the sun, hydrogen is undergoing nuclear fusion. Both of you are correct, so I'm not holding you incorrect. You're both correct. Hydrogen undergoes nuclear fusion, in which process portion of mass is converted into energy, following the equation E equals to mc squared. So the sun actually converts some mass into energy every single second. The sun loses a huge amount of mass per second, which it radiates out as energy every single second. Huge amount of mass. Yeah, I can show you just to convince you of this fact that how much mass loss of sun per second. Have a look. It loses about 5 or 6 million tons of material every second. So you convert that into energy. That's sort of like the energy output of sun. And we only receive a very small portion because we are pretty far away and our surface area of the earth is also pretty small. Then again, we cannot effectively utilize all the sun's ray that we use, that we receive on the Earth's surface. We can only use a very small portion. The key way the sun's energy is absorbed in our environment that we can actually use for further processes is by photosynthesis. And photosynthesis don't even use the heat energy. Photosynthesis only use a small portion of the visible light spectrum. And now we have some solar panels, but to tell the truth, solar panels are a very small fraction compared to the all photosynthesis that we have in the whole planet. Anyway, we have this natural available way. Plants, they do photosynthesis and capture the sun's energy, and that energy basically flows to the whole world. So whatever we are eating, whatever energy that we have, all of our cars and vehicles that move around, they are run by fossil fuels. Fossil fuel is basically the hydrocarbon, that is a hydrocarbon fuel that is stored underground, which was created by centuries of pressure and temperature coming from the fossils of dead animals and trees, and they were created over a long duration of time. And now we are digging all those up and eventually burning up them. So we are liberating a lot of carbon in the atmosphere, which is bad for the carbon because our temperature is rising extremely fast, likely to make the world inhabitable in a pretty short time. I mean, the way the Earth is heating up, if we do not drastically change our actions, maybe you kids are gonna see a regular world as you grow up, but your kids will not see a regular world. They are going to struggle just to survive on this planet, not because of food shortage. I mean, there will be food shortage because the temperature is going to stop production of a lot of crops that we know. I mean, the Earth is actually becoming uninhabitable. The rate of the imbalance is extremely high, like super high. Anyway, bad news is bad news. So if I want to talk about the energy conversion that comes from the sun, I have to say that the actual source of energy of the sun is mass of the sun. What is that? What is the material that holds this mass? Mostly hydrogen. Hydrogen converts into helium gas in the process of nuclear fusion, in which way it converts a portion of those hydrogen mass into energy, and that energy is radiated out from the sun in the form of electromagnetic radiation. So that's another energy conversion example. Then you can talk about a lot of other different type of examples. For example, how does a fan work? I mean, how does a fan work? For example, fan means ceiling fan. We provide electrical energy and it converts that into kinetic energy. It's pretty simple. How does light work? We provide electrical energy, it converts that into light and heat energy. One thing is pretty important that I would like all of you to understand that in any process of energy conversion, and I'll say it again, in any process of energy conversion, heat is pretty much in all cases a default byproduct, whether you want it or not. Heat energy is almost present in almost all energy conversion, whether you want it or not. There is a reason for this. The reason is that whenever energy conversion happens, materials move. Typically, materials move. So you have some sort of explosion, you have burning fuel, oil, or you are rubbing your hands together. So you're doing kinetic energy. So some sort of friction is always there. And whenever there is friction, particles collide with each other, they tend to gain higher kinetic energy, which is expressed as the increase of temperature of those objects. Hence, the heat energy is pretty much always a byproduct. Now, that is pretty important for us to understand that unless the question specifies a scenario where heat energy is not supposed to be created, unless the question specifies such a scenario, for example, air resistance is negligible, that is a certain condition which makes it possible for us to assume that heat energy loss will not happen because we're considering air resistance to be negligible or air resistance to be zero. But if you consider regular cases, whenever any type of energy conversion will happen, heat will pretty much always be a byproduct. Now, then comes the idea, why am I using the word byproduct? Why am I not saying that it will be an outcome? Why am I using the word byproduct? The reason I'm using the word byproduct because in many cases of energy conversion, we do not want heat energy to be produced, but heat is produced anyway. Even in cases where we want to produce heat energy, for example, you are trying to cook some material, you're burning a stove to burn some natural gas or some LPGs, liquid pressurized gas, or maybe you're even using an induction cooker, you're using electrical energy to do some induction cooking. So even in cases whenever we want to convert into heat energy, all the heat energy cannot be used. So I'm trying to slowly move to the idea of efficiency. So what I'm trying to get at is that, let's say we have some available amount of supply energy. Let's say that amount of available energy is maybe, let's say, 10,000 joule. I want to convert this available form of energy into some other form of energy. For example, let's say I have some liquid fuel which has a total energy content, available energy content, chemical energy content of 1000 joule. Now, if I start to burn this to liberate the heat energy out of it, the question is, do I want the heat energy or do I want something else? For example, if you consider that thing for the case of a car or an automobile, you do not want that chemical energy to be converted into heat energy. Your expected form of output is kinetic energy. But you cannot do without the heat energy because the primary form in which the chemical energy will be liberated, by means of the burning or controlled explosion, the chemical energy will be initially liberated in heat form. Then through some very, very, very beautifully designed devices called engines, through reciprocating engines or rotary engines, we will convert that heat energy into kinetic energy. So, and it is impossible to absorb all the heat energy of the system into kinetic energy. So by default, you will always have some loss. So this is one of the reasons. This is basically where the idea of efficiency comes in. Efficiency basically means efficiency is given by the expression is equal to, if I only write useful divided by total, I can only write this much just to make sense with you. এরপরে কি হবে সেটা আমি পরে বলতেছি। Into 100%, I'm using 100% because efficiency is usually expressed in terms of percentage, because we have to do the efficiency using similar terms on the numerator side and also on the denominator side. So it can be useful energy divided by total energy. Sometimes to specify these two type of energy, we also add one more term, that is useful output energy. Useful output energy means the type of energy that we want. Total input energy. So these are the two terms sometimes we also use. So we can choose either to do the ratio of energy and energy, or we can choose to do the ratio of work versus work, or we can do the ratio of power versus power. But you cannot do a ratio of work versus power. You cannot do a ratio of energy versus power. Energy versus work is still doable because energy and work are interconvertible quantities. I'll talk about that after a while. So এটা হচ্ছে আমাদের efficiency basic concept. This is not L, this is just an arrow over here. So if we have 10,000 joule of worth of chemical energy, and if you want to convert that to as kinetic energy of a vehicle, it's pretty much possible that you might be able to convert about half of the energy into kinetic energy of the car. The rest of the half of the energy, so 5,000 joule will be converted into kinetic energy, and maybe 5,000 joule wasted as heat that you have to give up for the process to run. So এই যে প্রসেসটা বললাম যে আমাদের কিছু amount of energy সবসময় লস হিসেবে কাউন্ট হবে. Now you have to understand what is the definition of loss. How do we define loss? Any energy form that is produced out of our available stockpile of energy, our starting form of energy. Any energy form that is unexpected or that is not needed is what we can define as loss. যে কোনো এনার্জি টাইপ যেটা আমাদের জন্য প্রয়োজন না সেটাকে আমরা লস বলতে পারবো. যেমন একটা এক্সাম্পল তোমাদেরকে বলি, এই যে আমি তোমাদের সাথে কথা বলতেছি, the lecture that I'm trying to give you, my voice is traveling from my vocal cords to my buccal cavity, coming out of my mouth, vibrating the air molecules, then vibrating the microphone in my headphone system, which is transmitting the data through the wire, and then eventually through some magical process of internet, eventually you are able to receive it. Now think about it. As I am making my voice sound, a very small fraction of sound energy is actually captured by the microphone. And because of the vibration that I'm producing in the air, this delivered energy from my vocal cords, which is made possible by means of spending some chemical energy that I have stored within my body, which I gained from some sort of food. So in my body there was chemical energy. The muscles of my vocal cord are pulling it in a very controlled manner, which is producing a certain type of vibration, which we can understand as English language, and that vibration is producing sound energy into the air. This sound energy eventually dies out, and that actually increases the temperature of the room. Now here's the catch. In this process of me giving you the lecture, it is not my will to increase the temperature of the room. An efficient process would have been if I could produce exclusively the amount of energy needed to vibrate the microphone. If no energy from my mouth would be wasted into the atmosphere, that would have been a better efficient process. So আমি যতটুকু এনার্জি আমার খরচ করা দরকার এক্স্যাক্টলি অতটুকু যদি খরচ করতে পারতাম তাহলে আমার প্রসেসটা 100% এফিশিয়েন্ট হতো, বাট এটা প্র্যাকটিক্যালি পসিবল না. সবসময় দেখা যায় যে আমাদের কিছু না কিছু এক্সট্রা জিনিসপত্র ওয়েস্ট হয়. যেমন আরেকটা এক্সাম্পল তোমাকে বলি, এফিসিয়েন্সি বোঝানোর জন্য আমি তোমাকে প্রথমে বললাম ফর্ম নিয়ে কথা, এরপর বলছে হচ্ছে প্রসেসের মধ্যে যে ফ্ল গুলো থাকে সেটা বলছে. আরেকটা সিম্পল এক্সাম্পল বলি, দিস মাইট বি ইভেন বেটার আন্ডারস্ট্যান্ডেবল. লেটস সে you want to cook some potato. Let's say you want to boil some potato. What is your aim? You want to boil some potato. Boil means water boil. ঠিক আছে? So your aim is to transfer some heat energy into the potato such that the potato will be boiled. That is your expected process. You have some starting form of energy. You want to transfer it to where? The potato, so that the potato will be cooked. But if whenever we will start to cook this thing, a lot of things can happen. You will turn on the stove. You put a cooking pan onto the top. You'll fill up that cooking pot with some water, and then you put down the waters into them. To make the potatoes get boiled, we have to heat up the cooking pot. We have to heat up the water inside the cooking pot. We will also lose some significant amount of heat energy because of the convection current through which the flame is going out. So we cannot practically capture all of the heat that the flame is creating. So a lot of the heat energy that we are producing by burning the fuel is practically not going into the location where we want to send it. It is going in somewhere else. এই পুরো জিনিসটাই practically একটা waste. In this case, the form is still heat energy. আমাদের টোটাল এনার্জিটা হিটেই কনভার্ট হচ্ছে. একটা আমাদের কেমিক্যাল এনার্জি বার্ন করে সরাসরি হিটই হচ্ছে, এবং আমাদের এক্সপেক্টেড ফর্ম অফ এনার্জি হচ্ছে, কারণ আমাদের পটেটো কুক করার জন্য আমাদের হিট এনার্জি দরকার. বাট টোটাল যতটুকু কেমিক্যাল এনার্জি বার্ন করে আমি হিট এনার্জি লিবারেট করতেছি, ওই সবটুকু হিট এনার্জিকে আমি পটেটোর ভিতরে ঢুকাতে পারতেছি কিনা? আনসার হচ্ছে না, আমি চাইলেও এটা পারবো না. কারণ আমাকে পটেটো বয়েল করতে হলে আমার হিটিং পট, সেটা আমার কুকিং পটকেও হিট করতে হবে, তার ভিতরে ওয়াটারকে হিট করতে হবে. উইদাউট ডুইং দ্যাট ইটস ইম্পসিবল. আই এম নট বেকিং ইট. বেকিং হলে আবার ডিফারেন্ট ইস্যু হইতো, বাট ওইখানেও লস হইতো, কারণ তোমাকে বেক করতে হলে কি করতে হতো, ওই ওভেনের ভিতরে যে এয়ারটা আছে সেটাকে হিট আপ করতে হতো. বাট তোমার এম তো পটেটো পাক করা, তোমার এয়ারকে হিট আপ করা, বাট এয়ারকে হিট আপ না করে তুমি পটেটো পাক করতে পারবা না. So the point I'm trying to make that every process has some way of wasting energy উইদিন ইটসেলফ। এই প্রসেসগুলোকে যত মিনিমাইজ করে আনা যায়, যত বেশি এই মানে ডাইভার্টেড অ্যাওয়ে এনার্জিকে রিক্যাপচার করা যায় বা আমাদের প্রসেসের এক্সাক্ট এইমের দিকে ফ্লো করানো যায়, একটা সিস্টেমের এফিসিয়েন্সি তত বাড়তে থাকে। This is basically where turbochargers are used. Do you guys know what a turbocharger is? Anyone? না জানলে সমস্যা নাই, আমি বলবো। I'm trying to pick up relevant examples to make it interesting. Turbocharger is basically a system. Turbocharger একটা ছবি দেখালে হয়তো আর একটু ভালো বোঝা যাবে। ওকে, এইটা একটা খুব ভালো ফিগার। প্রমাণ, এই ফিগারটাকে দেখা যাচ্ছে? মানে তোমার এই ছোট ছোট লেখাগুলো কি পড়তে পারতেছো?
Yes, sir.
আচ্ছা, so might as well open new image. Okay. Oh, beautiful, bigger image. So আমি বেসিক জিনিসটা বুঝাই। এটা হচ্ছে আমাদের টার্বো চার্জিং। এখানে অনেক কিছু দেখানো হয় নাই, the lots of things are not present here, but actually what are we doing? Try to understand, whenever an engine burns fuel, it has to absorb air from the atmosphere, it has to take in air, then it will mix that air with the fuel that you have, petrol, diesel or octane, and then either by spark or by auto ignition process of the high temperature, the fuel will burn. So you are taking air from the atmosphere, you are taking fuel from the fuel tank, mixing them up, burning it. So essentially normally চিন্তা করো যে আমরা যখন একটা সার্টেন ফুয়েলকে বার্ন করব, আমাদের এই পিস্টনটাকে মুভ করার জন্য আমাদের এখানে একটা সার্টেন অ্যামাউন্ট অফ প্রেসার ডেভেলপ করা লাগে। প্রেসার ডেভেলপ করার জন্য কি দরকার? হিট এনার্জি দরকার। এখন আইডিয়াটা হচ্ছে আমাদের যদি আইডিয়াটা হচ্ছে যে এটা কি টার্বোচার্জার নাকি? হ্যাঁ, এটা টার্বোচার্জার। হ্যাঁ, ঠিকই তো আছে। এটার বেসিক আইডিয়াটা হচ্ছে, আমি বলতে চাইছিলাম হচ্ছে রিহিট সিস্টেম, বাট অ্যাপারেন্টলি আই মেসড আপ। দাঁড়াও 1 মিনিট। আচ্ছা, আমি মনে হয় টার্মটা মিস আপ করে ফেলছি, বাট লেট মি জাস্ট টেল ইউ হোয়াট আই হ্যাড ইন মাইন্ড। আইডিয়াটা হচ্ছে এরকম, মনে করো এটা হচ্ছে আমাদের একটা ইঞ্জিন ব্লক। এই ইঞ্জিনের ভিতরে আমাদের ফুল বার্ন হবে। এখান থেকে আমাদের বের হবে হচ্ছে হট এক্সস্ট গ্যাস। ওকে, এবং এই ইঞ্জিনটাকে রান করার জন্য আমাদের ফুয়েল ট্যাঙ্ক থেকে ঢুকতে হবে হচ্ছে ফিউল, এবং অ্যাটমসফিয়ার থেকে আসতে হবে হচ্ছে এয়ার। এখন if we want to achieve a much higher performance of the engine, this intake air can be heated up a little bit, because what you have to understand, when the engine will do that explosion, if this air is cold, a portion of the fuel's chemical energy will be used to heat up this air as well. So if the air comes in cold, a part of the energy of the chemical energy of the fuel will essentially be needed to heat up the air that we are taking in. So can we somehow provide that heat energy from a different source? The answer is yes. How does this happen? This actually happens that the intake air is absorbed by a certain set of tube. Let's say this is a blue tube, and through which the hot exhaust of the car runs through a different channel, and which are placed side by side. So what I want you to understand, that the blue lines are the clean air intake pipe, and the red line is the hot exhaust output pipe, and in a certain location they are placed in close vicinity to each other, but with a shield between them. So there is a metal barrier between them, so you can have concentric pipes like this. For example, let's say this is the hot air intake pipe, and around this we have the exhaust pipes. So the exhaust gas is going to run through this channel, and the hot and the cold air is going to be sucked into the machine through this channel. So you can have concentric valves. So the way this will work, that as the hot exhaust comes out within this heat exchanger, the incoming cold air and the hot coming air will be somewhat warmer than regular atmosphere. Maybe you can get as up to 10-15 degrees Celsius of temperature increase, which is a huge thing for the engine's performance. So in this way, we can actually recapture some of the waste heat, which if we didn't use this device would be all wasted. But in this case, by having this heat exchanger thing installed, we can actually recapture some of the engine. Now you might wonder that do all cars have this? The answer is solid no. The reason is that this will make your engine efficient, but efficiency, can have a lot of other aspects. For example, this device you will be installing in your car will have some mass, which means if you install this device within your automobile, if you are driving, you have to move that mass as well. So work will be needed to be done by simply the chemical energy of the fuel to move this thing. So some energy will be lost because we have this extra added mass within the car body. Do we want that? Okay, if we want that, then we can install it. If that's not a feasible idea, for example, let's say using a heat exchanger for a certain car, maybe using a heat exchanger using a certain car, in 1 second you can save, let's say 200 joule. But it just so happens that for that specific car design, the weight of the heat exchanger happens to be such big that in 1 second you have to physically do work that is 300 joule. So if our energy gain is 200 joule, where the work done is actually 300 joule, so practically this means that you have installed the device that is eating up 100 joule of chemical energy from the system. It is not actually adding benefit to your system. So if it has to be beneficial, then this absorbed energy should be significantly less than 200. That way this can be a feasible device. Then again, there are other things to consider. For example, there are certain scenarios where any added mass can be something that we don't want to have. For example, do you know what Formula 1 racing is? Anyone? Formula 1? আমার কথা শোনা যাচ্ছে না। হ্যালো,
Sir, can you repeat?
do you know what is Formula 1 racing?
No, sir.
Yes, sir.
Yes, sir.
Some of you know. আমি কি বলতেছি এগুলো কি বোঝা যাচ্ছে? বোঝা না গেলে তোমাকে কোশ্চেন করো বা raise your hand. I have my eyes on this participant list. Just do that so that I can try to make it clearer. আমি অনেকগুলো কথাবার্তা বলেছি এই জন্য যে তোমাদের কনসেপ্টটা বোঝার জন্য এই জিনিসগুলো মাথায় ঢোকা দরকার, এবং এগুলো থাকলে তোমরা আনসার মেকিং করার সময় লজিক্যাল সিকোয়েন্সটা মেস আপ করবা, যে কোনটা থেকে কি হয়, কেন কোনটা হয়, এই জিনিসগুলি। ম্যাথমেটিক্যাল ইকুয়েশন দিয়ে ম্যাথমেটিক্যাল ইকুয়েশন তোমাকে লিখে দিলাম এক গাদা, তারপর তোমাকে এক গাদা ম্যাথমেটিক্স করানো, তুমি সবগুলো ম্যাথস করতে পারলা, that is pretty much doable. That is a simpler part, but being able to understand, visualize a certain process to its very itsy bitsy detail is what makes physics interesting, in my opinion. To some people that can be the difficult part of the physics, but in my opinion that's what makes physics interesting. Formula One is the racing of these kind of cars, which are pretty much the very peak of automobile industry. All the brand new cutting edge technologies are applied and tested in these vehicles. For these vehicles, acceleration is a pretty huge factor, and acceleration comes from two things. Acceleration comes from what? F equals to ma. So any added amount of mass or a certain amount of force that you produce out of your tires, any higher mass will reduce the acceleration, which can be a highly penalizing factor for a Formula One car. So a Formula One car might choose not to use a turbocharger because they don't want to have very good mileage, rather they want really fast cars. So in that aspect, even though it might be a good idea, for their specific requirement, using a heat exchanger device is not a very feasible thing. So it depends on a lot of different factors. But the point I'm trying to make that if we want to increase the efficiency of a system, then we should try to produce as least as possible waste heat form, and whatever waste energy form is produced, we should try to capture them and add them back into the system or back into our process as much as possible. It's not actually possible to capture them 100%, but the more we can do, the higher the efficiency will go up. Because in that case, you have to understand this thing that using the idea of law of conservation of energy, what that is, I'm going to talk to you about the same. Actually, let me just talk to about it in a second. Derivation. Law of conservation of energy. The word conservation means something being constant, something being unchanged, something being the same as before. Conservation, that word means that something remaining unchanged. So conservation of energy means the amount of energy remaining constant. Law of conservation of energy means the law that tells us about energy being constant. What is the law of conservation of energy? Law of conservation of energy actually tells us that energy cannot be created or destroyed. It can be only converted from one form to another form. This is almost true, not entirely true, because in nuclear cases, mass and energy are interconvertible. In some cases, mass can be converted to energy. In other cases, energy can be converted back into mass, which both of them are interconvertible. But we are not actually talking about the microscopic, the atomic level or nucleus level. We are talking about scales, which is a macro scale. Macro scale means we are talking about basic energy conversion processes, excluding the nuclear reactions. So things that we regularly experience in our life: burning something, muscle and pushing something, and the IC engines, so on and such and so forth. So for typical regular experience examples, energy can be considered to be a constant quantity. Same thing goes for mass as well. One of the property of any chemical reaction is that in any chemical reaction, total mass of the reactants before and after the reaction remains the same. The mass of the material simply doesn't become gone. Some chemical reaction can produce gases output, but if you capture the gas material and measure its mass and add it up all together on the output on the reactant reactant converts into products. If you add up the mass of the gas with all the other products that you have out of chemical reaction, eventually you will end up with the same amount of mass that all of your reactants had. So the law of conservation of energy basically tells us the total amount of energy of a system remains constant. Energy cannot be created or cannot be destroyed. It can be converted from one into another form, which brings us to the idea that in any energy conversion process, total input energy equals to useful output energy plus lost energy. So এটা হচ্ছে আমাদের যে কোনো এনার্জি কনভার্সন প্রসেসের বেসিক এনার্জি ইকুয়েশন। যতটুকু এনার্জি দিব তার মধ্যে একটা পোরশন ইউজফুল হবে, বাকি পোরশন পুরোটুকুই হবে লস। সো এনিথিং দ্যাট উই ডোন্ট ওয়ান্ট টু বি লস will be useful and vice versa. There is one more thing, one more example that I'd like to discuss before I start giving you the equations in terms of discussion thing. I would say আচ্ছা, বিফোর আই গেট ইনটু দ্যাট, তোমাদের এই পর্যন্ত কথাবার্তার মধ্যে কার কোনো কোশ্চেন আছে কিনা?
No, sir.
No, no, sir.
আচ্ছা, তোমরা কি শুনতে শুনতে ঘুমাই যেতেছ?
No.
I understand it's pretty late and this class was set to be pretty late. তোমরা শুনো, আমি eventually lecture আপলোড করে দিব, সো কিছু মিস করে গেলেও প্রবলেম নেই। আর যদি if you're feeling really tired and you're sleepy, I'm not seeing you, I don't want to hold you in judgment point. I would request that you just get up, go around, walk about a little bit, do some 30-second plank, twist your waist and do something, do some free aerobics, disturb your elder brother, younger brother a little bit, eat something out of the refrigerator, and then come back, take some 1-2 minute walk around the house. It usually helps, at least for some time. And whoever you are disturbing, you are on your own. I did not tell you this. Damn, that is on the recording. Anyway, you get my point, right?
Yes, sir.
I hope so. So the other thing that I'd like to discuss for the topic of the efficiency thing is that efficiency is also highly dependent on what we want out of a system, out of a process, energy conversion process. The same energy conversion process, depending upon our perspective, can have different efficiency. I'll say it again. The same energy conversion process, depending upon our perspective, depending upon our expectations, can have different efficiencies. One example that I'm going to give you is in the bakery, in a bakery shop, they put in, bakery example is consider a filament lamp. তোমরা কি ফিলামেন্ট ল্যাম্প জীবনে দেখছো কেউ? তোমরা তো হচ্ছে মানে অ্যাকচুয়াল ফিলামেন্ট ল্যাম্প দেখছো কিনা? হলুদ রঙের বাতি জ্বলে, এগুলোতে ব্যাডমিন্টন খেলে, এখনো খেলে, এখন সবাই এলইডি লাইট লাগায় খেলে। বাট হ্যাভ ইউ কিডস সিন ইট?
Yes, sir.
আচ্ছা, for those who might
Yes,
have
sir.
not seen it, this is how a filament lamp looks like. Just trying to make the lecture inclusive. A filament lamp, filament bulb looks somewhat like this. So you have this glass thing, and here comes two thick wires, and these two wires actually are the plus and minus, or the live and neutral connection of the supply. And this small tiny thing that is over here, I mean, this is a spring-like material. This spring-like material is basically what you call the filament. It can heat up really well, and it will then start to glow because of the heat energy, in which case it will be producing light energy because of the high temperature. And because I just said high temperature, it also means that these bulbs produces a lot of heat along with light as well. So filament lamps are a good source of light and heat both, but I mean, they produce a lot of heat, and alongside they also produce some light energy. Now, and these small wires that you see at the center, or maybe these two wires that you can see over at the center, they are basically supporting the filament lamp over here. Because if we didn't use these supports, this whole spring material would be wobbling, and wobbly things are not very stable. So we have those support points. They are not part of the electricity supply point. They are just over there to support the thing, and their resistance is also very, very high. Consider a filament lamp. The filament lamp's energy conversion looks like this. We have electrical energy converting into light plus heat energy. So light energy plus heat energy. আমি এই লিখতেছি না, তোমরা পরীক্ষা লিখবা। এখন এই একটা বাল্ব, এখন মনে করো একটা certain filament lamp-এর property হচ্ছে, in 1 second of time, let's say it takes in from the source in this case can be a battery, can be the supply of the house. Let's say in 1 second time it absorbs 250 joule of energy, and it converts 140 joule of it into light, and it converts the remaining 110 joule of energy into heat. Let's say this happens. Now, example 1, try to understand and keep your ears open and your mind open. if you use this filament lamp as a reading lamp on your study table, all that you want in this process is only light. In this case, whenever you're using it for the example of a reading lamp, what do you think will be the useful energy output? Follow.
140 joules.
Precisely. So if you're using it for a reading lamp, the useful energy will be 140 joule. সেখানে জুল লিখে দিই, তাহলে আমাকে আর প্রত্যেকটা জুল লিখতে হবে না। And in this case, because if you use as a reading lamp, the heat is unnecessary. We don't want the heat to go. In that case, the waste would be 110 joule. As a second example, do you kids know what an incubator is?
Yes, sir.
Yes,
What
sir.
is an incubator?
Yes, sir. মুরগি ডিম রাখে এখানে।
Sir, it is like for heat, so that like people or things that require heat, but they are not receiving heat. That is why we keep it in an incubator.
Yeah, incubator can be used for other for that purpose as well. Incubator is basically artificial egg hatching machine. Artificial egg hatching machines. They are generally called incubator. However, when the chickens come out of their egg, if we want to keep them warm, we can also keep them in the incubator by lowering the heat a little bit so that they don't get fried off, but they are in a comfortable temperature. Achha. Incubator is basically an alternative to a live chicken, live hen. So incubator আমরা কি করি, আমরা হচ্ছে একটা সার্টেন কেস থাকে, এখানে একটা ক্লোজড এনভায়রনমেন্ট থাকে, হিট ইনসুলেটেড এনভায়রনমেন্ট থাকে, এখানে আমরা অনেকগুলো এগ রাখি এবং সামহাও আমাদেরকে এই এগগুলোকে হিট আপ করতে হয়। একটা ইনকিউবেটরকে হিট আপ করার খুব কমন মানে রেডিলি রিপ্লেসেবল এবং ইজি টু ইউজ টেকনোলজি হচ্ছে আমরা যদি এখানে কিছু ফিলামেন্ট ল্যাম্প ইউজ করি। ফিলামেন্ট ল্যাম্প সিগনিফিকেন্ট হিট প্রডিউস করে। ফিলামেন্ট ল্যাম্প ইউজ না করে আমরা এখানে ইলেকট্রিক হিটারও ইউজ করতে পারতাম, বাট filament lamps are really available in a lot of places around the whole globe, and they are quite cheap to replace. Filament lamp একটা নষ্ট হয়ে গেল 40 টাকা দিয়ে filament lamp লাগাই দেয়, ঠিক আছে? It's quite easy to use. So let's say a certain incubator design uses filament lamp for this heating purpose. এখানে যে আপনি দেখো এই ডিমগুলার কিন্তু these eggs do not need light energy because they don't even sense it. All that you need for this device is the heat energy output of this filament lamps, which means if we are using this exact filament lamp within our incubator, in that case, how much do you think would be useful energy?
110 joules.
You have 110 joules and the waste would be 140. So same process, but depending on what you want, you have different outcome. Last example, a bakery. Bakeryতে যে জিনিসটা হয়, bakeryতে বিস্কিটগুলোকে crispy to keep the cookies crispy and also to display them beautifully to the customers, they use this kind of metal boxes which has a glass in front of them and metal tops on it. They have some opening cap over here, and inside they usually have a filament lamp over here, and you have all the cookies over here, which are kept dry and also well displayed by this filament lamp that we have. So this kind of there are quite a lot of these kind of boxes. Sometimes that can be in a shelf format, but the point I'm to make that we use filament lamps over here for two purposes. We want the customers to be able to see the biscuits properly, so we need the light energy, usefulness one. Also, that heat energy available from the filament lamps keep the biscuits dry and crispy. So it's a good quality for the cookies. So in this case, both of these two types of energy is expected. We want the biscuits to be well illuminated. We also want the biscuit to be crispy, which means for the case of a bakery, how much is useful and how much is waste?
250 joules useful and 0 waste.
Precisely. So same thing, same device, depending upon how we're using it, we can have different outputs. এই অ্যাসপেক্টটাকে, এই কনসেপ্টটাকে বুঝা গেছে যে আমাদের জাজমেন্ট করতে হবে, একটা প্রসেসকে মানে মুখস্থ করে ফেললে হবে। তোমার বুঝতে হবে যে আমরা আসলে কোন পার্সপেক্টিভ থেকে একটা জিনিসকে জাজ করতেছি। ওটার উপর বেস করে পুরো ম্যাথটি পুরো হিসেবে কি হতে পারে, ডিফারেন্ট হতে পারে। এই পর্যন্ত ক্লিয়ার কিনা বলবান?
Yes, sir.
Yes, sir.
Yes, sir.
I'll take a small break, 5 minutes. I'll be back in 5 minutes. তোমরা একটু হাঁটাহাঁটি করে আসো আর ওয়াশরুমে যাও। See you in 5. So these are some of the examples that we have. Then going back, if I go in reverse order, you can can discuss that some of the two of the types of energy sources. There are many energy resources that we use for our purposes. They can be divided into two main type. One, what we call renewable sources, and the other one is non-renewable sources. Okay, one thing is you should be very careful. Sometimes students mess up the definition because they didn't study well. They try to draw the definition from the name. Renewable resources are those energy sources which will not run out. Non-renewable resources are those which will eventually run out. এটা হচ্ছে দুইটা সোর্সের ডেফিনিশন। আচ্ছা, এটা বোঝার উপায় কি? ডিফারেন্সটা বলতেছি। Non-renewable energy resources are basically the fossil fuel and also like the atomic energy. So there are only two exclusive sources of non-renewable sources. One is fossil fuel. Fossil fuel can have three different types. We can have coal, the solid form. We can have oil, the liquid form. We can have gas, the gaseous form. And then atomic energy or nuclear energy, atomic, no? Nuclear fuel. Nuclear fuel basically means nuclear energy is obtained from this type of fuel, because this thing is also non-renewable, because whenever we liberate nuclear fuel is a very highly enriched source of energy, a very dense source of energy. I mean, okay, if I use the term, what do I mean by a dense source of energy? Dense source of energy basically means that if you consider in terms of per kilogram, what is the maximum amount of energy that you can get? So for example, 1 kilogram of oil, mineral oil, fossil fuel oil, let's say if it can give you, let's say, x joule of energy. Let's say 1 kilogram of oil holds x joule of chemical energy within itself. If you burn it all together, you can liberate x joule of heat energy altogether. In which case, a 1 kilogram of nuclear fuel, for example, uranium-235 nuclear fuel. I'm not running examples over here because there can be so many different radioactive isotopes. The most common two isotopes are, one is uranium-235 and another isotope of plutonium is Pu, but I forgot the mass number, so I'm not writing this. So 1 kg of nuclear fuel can have about, I think, I don't exactly remember, but this can have about I think 10,000 or 1 million times the energy of that of a kg of oil. So in terms of energy, we consider the nuclear fuel to be highly energy dense. So there's a lot of energy in there, but liberating the nuclear fuel's energy requires a lot of setup, a lot of precautions, and it's not as easy as it sounds. And if properly handled, nuclear fuel can actually be a viable solution for all of our environmental problems that we have currently in the world, if properly handled. So there is a pretty big if. But with the amount of nuclear fuel that we have available on our Earth crust and that we can mine through different mines, other than burning fossil fuel, currently using nuclear fuel can prove to be a pretty good alternative just to jump right now into till the point that we can become totally sustainable depending upon the renewable sources. So these are the two types of non-renewable sources that we have on fossil fuel and the nuclear fuel. The idea is that the more we'll be using these two types of resources, slowly but surely, their reserve amount, their initial amount will become less, and they are not replenished automatically. So we are using it means once it's spent, it is not automatically becoming available, because it took thousands of years, millions of years for the fossil fuel to be created. And the nuclear fuel that we make available to us by the nuclear fission process of the radioactive isotopes, we inherited those particles from some celestial process. With your creation process, I'm not getting the creation of this nuclei, but the total number of those nuclear atom is limited on the Earth crust. No matter how big they are, there is a certain number. We can always find more and more mines for us to get more of these isotopes, but the more we use it, the less it becomes, without a doubt, because they are not created back. So this is the truth of non-renewable energies. Renewable energy resources, on the other hand, can be a lot. There are a lot of different examples. One simple way to remember that what are renewable energy resources is that something that you need to think, that if you think that you will be able to attribute it directly to the sun or the moon. Some sort of energy resource that is directly attributed and continuously replenished or continuously driven by the sun and the moon. The moon is actually not a very big player. Mostly the energy comes from the sun, because you have to understand that the illumination of the moon comes from the reflection of sun. So that's there. But apart from that, the moon also provides a huge role in the tidal energy. That's why I'm including the name of the sun, of the moon as well. So renewable energy sources can be a lot. For example, if you consider the very simple example, the solar energy, we have some solar panels which are called photovoltaic cells. I'm going to write that word. So the first thing that I'm discussing is solar. I'm going to write upwards so that I can have space. So let's say I'm discussing solar over here. So solar panels are also called photovoltaic, PAIC, photovoltaic cells. So we're calling them cells because pretty much like typical cell or battery, they can give us voltage. Photovoltaic, basically, this is a single word. Don't consider this to be a different word. This is a single word. Photovoltaic means something that produces volts out of photo. Photo means light. Volt basically represents electricity. So photovoltaic cells are those which can convert light energy directly into electrical energy form, which is a useful output. That's one thing. We can also have solar thermal plants. Solar thermal plants are basically some sort of concentrated convection plants, or we can have solar reflection plants. So they are also solar thermal plants. We can have a lot of mirrors reflecting the rays of sun into a very single point, into one single point, and eventually producing a concentrated beam of light that can give us the purpose that we want to have. For example, a couple of days earlier, I actually shared one video to on the cactus. So like a video that I hope I can find this. It's pretty interesting to give a bit of an idea that what a solar thermal power plant is. Okay, I want to find the Olevel group. Did I send that video to your channel? Yeah, I sent it to your channel. Did you see this thing?
Yes, sir.
Okay. For those who are new or have a look. Have a look at
This is a giant lens, and I am using fog to illustrate how the sunlight is focused to a point. All the energy that hits this lens funnels into that spot. So when I put a rock under it, it is rather amazing. You can see how the rock is being etched and then melts from a different angle, and as I take the light off, you can see the rock is molten and turns to obsidian. This is a giant lens, and I am using fog to illustrate how the sunlight is focused to a point. All the energy that hits this lens funnels into that spot. So when I put a rock under it, it is rather amazing. You can see how the rock is being etched and then melts from a different angle, and as I take the light off, you can see the rock is molten and
on a cloud.
আচ্ছা ভিডিও মিট করে দিচ্ছি আমি সরি ভিডিওটা অ্যাকচুয়ালি সাউন্ড দরকার নাই বাট বুঝা গেছে কিনা সো এখানে বেসিক্যালি কিন্তু আমরা সোলারের লাইটটাকে ইউজ করতেছি না, সোলারের যে হিট প্রপার্টিটা আছে, ইনফ্রারেড রেডিয়েশন যেটা আছে সেটাকে আমরা কনসেন্ট্রেট করছি। So this can be thought of in a much bigger scale. For example, in this place, or other than using a rock, we can use a boiler which is going to boil some steam. That steam is going to be converted into high pressure steam that can be blown onto a turbine. Turbine will rotate. Rotation can be fed into a generator. Generator will convert that kinetic energy of the turbine into electrical energy by means of electromagnetic induction. So that ওই সিকোয়েন্সটা আমি একটু পরে ডিটেইলস আলাপ করব যে how do power plants work. So but আমি রিসোর্স গুলো নিয়ে আলাপ করি। So solar thermal plants can be like this, where we use the thermal energy of the sun for our heat generator, for our energy conversion, or to produce electricity out of it. So সেটা হতে পারে। So we can have solar, we can have thermal, I'm going to write solar thermal, because only solar plants basically means where we have photovoltaic cells. Solar thermal cells, so solar thermal plants means where we use the thermal part of the solar energy, and then we can have typical thermal plants, thermal power plants. If we ever come across this word, the thermal power plants, typical thermal power plants basically means plants which are run by some sort of fossil fuel, maybe coal, gas, or oil. So thermal power plant in general means power plants which are a bigger version of typical generator unit that we have. So they burn fossil fuel to produce electricity. Solar thermal is renewable. Then we can have wind energy. If you think about it, wind energy is also happens because of the sun's ray. The reason, one of the way I can explain the production of wind on Earth's surface is like this. Let's say the sun is over here, the earth is over here. So the rays of the sun are actually emitted in all directions, rarely outwards. But because earth is so small and quite far away, the beam of the sun's rays can be considered that they hit the earth's surface almost parallel to each other. Almost parallel to each other. That's an approximation. And this figure is obviously not drawn to scale. So why this is necessary for me? Now let me just show. Let's say on the earth's surface, let's say this is an earth crust, and on the midday, for this location on the midday, the sun's rays are falling in this way. I could actually draw a much bigger curve using this. So let's say this is the earth, figure not drawn to scale. On a certain time of the day, let's say the sun is delivering its beam of light in this orientation. So I'm trying to draw all of these lights, all of these rays parallel and equidistant. I'm trying to draw it in that way, but they are not all equidistant. So what you can see that if you try to understand that the concentration of the sun's rays would be the highest at this point, because this is here their beams are hitting vertically. But right around this place, or right around this place, the radiation would be more diffuse, more spread out over a larger region. So the temperature rise for this part of the Earth's surface and this part of the Earth's surface would be significantly lower compared to the temperature rise over here. So I'm trying to say that when this will happen, this will be the warmest of all the places around, and these locations, and also the place where there is night, this place will be cold. So there is a difference in heating. There's a difference of temperature. And whenever there is difference in temperature, what happens? Hot air goes up and cold air rushes in to fill up that void. ঠিক কিনা?
Yes, sir.
ঠিক আছে। সো এটা হচ্ছে মানে গ্লোবাল স্কেলে উইন্ড প্রডিউস হওয়ার একটা টেকনোলজি। এছাড়াও উইন্ড প্রডিউস হওয়ার আরো টেকনোলজি, ফর এক্সাম্পল তোমরা ক্লাস 6 অথবা 7 এর জিওগ্রাফি ক্লাসে হয়তো ল্যান্ড ব্রিজেস এন্ড সি ব্রিজেস পড়ছো কি? পড়ে থাকতে পারো, হয়তো ভুলে গেছো, সমস্যা নাই। ল্যান্ড ব্রিজেস এন্ড সি ব্রিজেস প্রপারলি এক্সপ্লেইন করতে হলে আবার হিট ক্যাপাসিটি কনসেপ্টটাকে ইনভলভ করতে হয়। আমি আপাতত হিট ক্যাপাসিটি কনসেপ্টটা ইনভলভ করতেছি না, কারণ হিট ক্যাপাসিটি তো আমাদের করাই নাই। জাস্ট আমি রেগুলার লেমেন টার্মসে যদি বলি, মনে করো এটা হচ্ছে আমাদের একটা ল্যান্ড, এটা হচ্ছে আমাদের একটা ল্যান্ড, এখানে মনে করো হচ্ছে আমাদের সি, ঠিক আছে, এটা হচ্ছে আমাদের সি। সো এটা হচ্ছে সি সারফেস, ঠিক আছে। সো সি সারফেস আছে হচ্ছে ওয়াটার, ল্যান্ড ব্রিজ ল্যান্ড আছে হচ্ছে ল্যান্ড ম্যাস, সয়েল অর স্টাফ। মনে করো in the day period when the sun is providing heat to equal amount to all of these places, both on the land and on the sea, it is a property of the land that the land mass, the soil, heats up faster for the same amount of energy, for the same rate of energy received, the land heats up faster or earlier compared to water or sea. তার মানে হচ্ছে মনে করো সকাল 6টায় সূর্য উঠলো, 6টা থেকে সূর্য হিট দেওয়া শুরু করছে, মনে করো দুপুর 12টার মধ্যে আমাদের ল্যান্ডের টেম্পারেচার হয়ে গেল হচ্ছে লেটস সে 30 ডিগ্রি সেলসিয়াস, whereas তখনও সি এর টেম্পারেচার থাকবে হচ্ছে মনে করো লেটস সে about only 24 ডিগ্রি সেলসিয়াস। দুটোই টেম্পারেচার বাড়বে, বাট ওয়াটার টেম্পারেচার বাড়বে কম, ল্যান্ডের টেম্পারেচার বাড়বে বেশি। সো এখন কি হবে, আমাদের ল্যান্ডের উপরের এয়ারটা উপরে উঠে যাবে, দিস উইল বি দ্য হট প্লেস, সো হট এয়ার গোজ আপ, and to compensate for the void, cold air is going to start flowing in from the sea. এই হচ্ছে আমাদের, এটা হচ্ছে আমাদের সি ব্রিজ, সি থেকে ব্রিজটা আসতেছে, ঠিক আছে। সো এটা হচ্ছে আমাদের দিনের বেলায় হচ্ছে। আচ্ছা, বা রাতের বেলা কি হবে, রাতের বেলা যখন সান ডুবে গেছে, সো এখানে ফার্দার কোনো হিট সোর্স নাই, both of them are hot, and because it is cold in the night, the warm objects radiate out their heat, they give up their heat, but it just so happens that within their property that the land cools up faster and the sea or ocean cools down slower. So মনে করো বিকাল 6টার সময় সূর্য ডুবে গেছে, যেহেতু সারাদিন হিটিং হয়েছে, মনে করো তাদের টেম্পারেচার মোর অর লেস সেম ছিল। সো সূর্য যখন ডুবে যাবে, মনে করো হচ্ছে উইদিন 2 or 2 hours, let's say at 9 PM দেখা গেল যে আমাদের ল্যান্ডের টেম্পারেচার হয়ে গেছে let's say 20 ডিগ্রি সেলসিয়াস, whereas still now the sea temperature এখন হয়ে গেছে হচ্ছে let's say 26 ডিগ্রি সেলসিয়াস। এটা পসিবল। So both of them cool down from their original temperature, but this one is retaining more heat, more temperature compared to the land. So এখন কি হবে, now this will work as the hot object, this is the cold object. So এখন আমাদের এই জায়গা থেকে আমাদের hot air উপর উঠে যাবে, and to fill up that void, cold breeze or cold air is gonna flow in from the land to fill up to this place. So এটাকে আমরা বলতেছি হচ্ছে land breeze, the breeze that is coming from the land. So এই যে দেখো once again, এই যে আমাদের টেম্পারেচার ডিফারেন্সটা প্রডিউস হচ্ছে, এটার মেইন একটা কারণ হচ্ছে দ্য সোলার হিটিং। ওয়াটার এবং there is a difference in property for between water and land mass or soil, that's very important, hands down, that's pretty important, but this property is only coming into our benefit because of the presence of the sun, because if the sun didn't provide us heating, they would always be in the same temperature. Because the sun is providing us heating, there is a difference of temperature, and that difference of temperature is responsible for the production of the wind. So as long as the sun keeps on orbiting around the earth and it keeps on radiating the heat energy, so for that long duration of time, for all those years to come, this land breeze and sea breeze will keep on happening. So this is how this is also a way by which wind is produced. So both of these same things are coming from attributed from the sun. Then beyond that we can have tidal energy. Tidal energy বুঝার আগে তোমাদেরকে আমি একটু hydroelectric energy নিয়ে আলাপ করি। So tidal একটু পরে বলতেছি, মনে করো let's say I'm going to go for hydroelectric energy first. Tidal এখানে থাক, tidal এখানে আসবো। আমাদের তো স্পেস আছে, আমি আবার জুম আউট করতেছি কেন? আচ্ছা, hydroelectric আগে বলি, এটা আমাদের এটা মুছে ফেলি। So then the other type of energy that we have, that is hydroelectric energy. Now what is hydroelectric energy? The name pretty much in this case is a good giveaway that what is happening over here. Hydro means water, electric means electricity. So by some mechanism we are using water to produce electricity. So how do we do that? From a high land or mountain range flowing down a river, we can produce some dam to produce a lake. So let me just show you an example. কোথায় জানো এখানে আচ্ছা, এই যে এগুলো হচ্ছে হাইড্রোইলেকট্রিক পাওয়ার প্ল্যান্টের বিভিন্ন স্কিমেটিক ফিগার, বাট এটা হচ্ছে মনে করো একটা হাইড্রোইলেকট্রিক ড্যামের একটা অ্যাকচুয়াল ভিউ। What is actually happening over here? When this dam did not exist, the river was further below the level. We erected this dam, we human beings made this dam over here and made the water trapped behind the dam, which ultimately accumulated and made this whole region of dry land into a lake, which basically means by obstructing the flow of water, we're accumulating a huge amount of water. And that is essentially submerging the riverside lands by a significant amount. As the water level grows higher, more and more land parts go underwater, and that's how this is designed. So when the water is stored over here, they gain GP. For example, now if we have a look at it, one of these basic figure that there is the dam, there is a reservoir, and at the bottom of the reservoir there is a valve house which is responsible to control whether we want to release water or not. Then there is a surge tank. The surge tank is actually over here, that just in case the water needs to overflow, we will allow the water to overflow out of this opening, and so that our devices are not destroyed by the pressure of water, by the force of water. And then we have this channel, which is a fancy name, penstock. So water flows in. So what is happening? Water is actually falling from a higher level to a lower level. So GP is converting into kinetic energy as the water falls down through this channel. And then this high kinetic energy property, high kinetic energy water is fed into a turbine. A turbine is basically a reverse propeller. So turbines are like a propeller kind of thing that if you give some axial fluid towards them, it can be gaseous fluid, it can be liquid fluid, they're going to take that energy and they're going to start convert that one directional energy into rotational energy. So basically the way a propeller works, propeller আমরা কি করি, একটা certain motor দিয়ে আমরা প্রপেলারকে ঘোরালে আমরা একটা certain fluidকে backwards move করতে পারি। In this, the turbine is just a reverse version. আমরা forward থেকে একটা single directional fluid flow দিচ্ছি, in this case the fluid is water, and that will convert that kinetic energy into rotary kinetic energy, and then the rotary kinetic energy is directly fed to a generator. Generator কিভাবে কাজ করে সেটা আমরা সিলেবাসের পরের অংশে দেখব, but when the rotation of the turbine is fed to the core of the generator starts to produce electricity. So তার মানে basically energy conversion হচ্ছে GP of the stored water converts to kinetic energy of the water, kinetic energy of the water converts into kinetic energy out of the turbine. It still remains kinetic energy, and then the kinetic energy is fed into the generator converts the kinetic energy into useful electrical energy form. So এটা হচ্ছে আমাদের hydroelectric power plant basic idea. The reason we are calling it to be renewable, because as long as this river will keep on flowing, as long as the river will keep on flowing, water will always be available here. As long as water is available here, we'll always be able to run this cycle. এখন কোশ্চেন হচ্ছে এটা রিনিউয়েবল কেন হলো? আমরা যদি এখানে ওয়াটার ইউজ করার পর যদি ওয়াটারকে এখান থেকে ইউজ করে ফেলি, তাহলে একসময় সব ওয়াটার শেষ হয়ে যাওয়ার কথা না? বলবান?
Yes, sir.
কিন্তু ওয়াটার তো শেষ হয় না। আর কথা হচ্ছে ওয়াটার কেন শেষ হয় না? একটা ফ্লোয়িং রিভারের ওয়াটার কেন শেষ হয় না? ফ্লোয়িং রিভারের ওয়াটার শেষ না হওয়ার কারণ হচ্ছে ওয়াটার সাইকেল। এখন তোমাদেরকে ওয়াটার সাইকেলটা বুঝাই, আজকে এইটুকু পর্যন্তই পড়াবো, বাট এই জিনিসটা খুব ভালো করে খেয়াল করো, ট্রাই টু আন্ডারস্ট্যান্ড। আমি একটা মনে করো ল্যান্ডস্কেপ আঁকতেছি, মনে করো এটা একটা বিগ মাউন্টেন রেঞ্জ, ঠিক আছে, বিগ মাউন্টেন রেঞ্জ। এই মাউন্টেন রেঞ্জ এখানে হচ্ছে ফ্ল্যাট ল্যান্ডস, ঠিক আছে, এরপরে হচ্ছে ক্রিয়া, তারপর মনে করো এখানে হচ্ছে মনে করো ওশান, এটা হচ্ছে ওশান। নাও ট্রাই টু আন্ডারস্ট্যান্ড, when the sun's heat energy hit all over the places, the sun is providing heat energy to all the places, we have evaporation out of all the water bodies, lakes, ponds, a puddle of water in a pothole of a road, the rivers, canals, also from the ocean as well. But just because ocean is a much wide continuous body of water with a lot of water, most of the the biggest fraction of the evaporation happens from the ocean. So ocean থেকে a huge amount of water কে মনে করো কি দিয়ে দেখাবো, water কে মনে করো পিঙ্ক দিয়ে দেখাইছি। So a huge amount of water is evaporated from the ocean. এই জায়গাগুলো থেকেও হবে, সমস্যা নেই। And because these things are pretty hot, because they're on the surface level, they start to rise up. As they rise up in the atmosphere, they start to cool down, and at a certain level of the atmosphere, they form the clouds. These clouds are basically accumulated water molecules which are not falling down due to gravity, but they are light enough to stay in the on the atmosphere. They have a certain mechanism, they form the cloud. The wind flow, the wind flow pushes this cloud onto the land. So এই ক্লাউড গুলো সব ল্যান্ডের উপর চলে আসতেছে, ঠিক আছে। ল্যান্ডের উপর সে কি করবে? They are going to start to deliver this water in three forms. So this water is going to fall onto this mountain region all over the land. I mean, mountain উপর আসতেছি একটা স্পেসিফিক বিষয়। The water that was evaporated out, converted into cloud, falls onto the higher lands, mountains, in three forms. We can have rain, we can have hail, we can have snow. We can also sometimes have fog, but fog is actually very small. So these are the three different forms that we can have. The hail and snow both are solid form. Rain, on the other hand, is liquid form. So we have rainfall over here, or hailfall, or snowfall over here. In the summer, when the temperature goes up, these things, or even the rain liquid, now দেখো আগে ছিল হচ্ছে আমাদের ওয়াটারটা ছিল হচ্ছে এই গ্রাউন্ড লেভেলে। সোলার হিটিং এর জন্য কি হলো, এই সবগুলা ওয়াটার অ্যাটমসফিয়ার দিয়ে এতখানি জিপি গেইন করলো। তার মানে কি, এখানে যদি 100 কেজি ওয়াটার থাকে, if we have 100 কেজি ওয়াটার ওভার হিয়ার and if this height is let's say 5 কিলোমিটার, তার মানে কি আমাদের এই 1000 কেজি ওয়াটার 5 কিলোমিটারের জন্য একটা জিপি গেইন করছে না? কনসিডার দ্য ওয়াটার মলিকুলস, করছে কিনা এসেনশিয়ালি?
Yes, sir.
এই জিপি গেইনটা হইছে কার জন্য? which source is responsible for this GP gain? Or in other words, if I ask you, absence of what would stop this process? Let me make it even easier for you. Why did we have the evaporation?
Solar energy.
Solar
Heat,
energy.
because of sunlight.
Because of the sun's heat energy. I wouldn't say light, because of the heat energy from the sun. Yeah, solar energy. So because the sun was there, we had evaporation, and that evaporation made all of these water molecules gain this much GP, and that the source of that GP is exclusively the available energy from the sun. And then the wind, which was also created by the sun, pushes those clouds onto the atop of the mountains, and as they fall over here, now those 100 kilogram of water, for example, is at a much higher level. Now, as they flow through the mountains, they flow through the land, and eventually goes back all the way to the oceans, they actually can have a lot of GP as they flow down. So আমরা যে কাজটা প্র্যাকটিক্যালি করতেছি, আমরা এরকম ফ্লো প্যাথের মাঝে মাঝে মনে করো এখানে একটা রিজার্ভার বানাইলাম, এখানে একটা রিজার্ভার বানাইলাম, আর এই জায়গাতে আমরা একটা টারবাইন হাউস প্লেস করলাম। সো বেসিক্যালি এইটুকু হাইট ফল করতে আমাদের যতটুকু জিপি অ্যাভেলেবল ছিল, অতটুকু জিপি আমরা ইউজ করতেছি। আমরা কিন্তু পুরো রিভারের সব ওয়াটার জিপি ইউজ করতে পারবো না, বিকজ দ্যাটস নট লজিক্যাল or not possible to make. কনভিনিয়েন্ট লোকেশনে আমরা লেকগুলা বানাই। সো এই জিপিটুকু আমরা ইউজ করছি। সো যতদিন পর্যন্ত সান আমাদেরকে লাইট দিতে থাকবে, হিট এনার্জি দিতে থাকবে, এই ওয়াটার সাইকেল চলতে থাকবে, এবং এইখান থেকে এখানে জিপিটা সবসময় কি হতে থাকবে, অ্যাভেলেবল হতে থাকবে। থাকবে কিনা? তার মানে হচ্ছে প্র্যাকটিক্যালি হোয়াট আই এম ট্রাইং টু টেল ইউ, এই যে এই হাইটে যে ওয়াটারটা আসলো, this water that we got found out over here is continuously being provided in this location by means of sun's energy, solar energy. So that's why hydroelectric power plants is a renewable energy resource. Once you construct it, as long as the sun is there, we will have no shortage of electricity out of the plant. We have to maintain the device so that it works properly, but the main energy of the GP of the water will be available readily just behind the dam because of the water cycle, because of the evaporation, because of the thermal energy of the sun. Did this whole thing make sense?
Yes, sir.
Yes, sir.
আজকে এইটুকু থাক। নেক্সট তোমাদের টাইডাল এনার্জি এবং জিওথার্মাল এনার্জি এগুলো নিয়ে কিছু জিনিসপত্র আলাপ করবো। দেন তারপর হচ্ছে তোমাদের ম্যাথমেটিক্যাল প্রবলেমগুলো দেখালাম। ম্যাথমেটিক্যাল প্রবলেমগুলো আমি ফার্স্ট শুরু করে নিই বিকজ দে আর প্রিটি monotonous and I want to go through the interesting and intriguing part of this chapter, which in most cases cause the students to have some confusion about. So আমি ওই পার্টটুকু আগে হ্যান্ডেল করলাম। নেক্সট ক্লাসে এইটার বাকি পার্টটুকু আলাপ করে ইনশাআল্লাহ আমরা ডিসকাস করবো। সো আমাদের নেক্সট ক্লাস হচ্ছে কখন? স্যাটারডে 7:30, ঠিক আছে?
Okay, sir.
Assalamu alaikum everyone. Thank you for the late
Allah
class.
Hafiz.
Allah Hafiz.